All right, so now that we've established that derivatives of vector value functions work like you'd expect, now we can use derivatives the way that you'd like to from all your experience of derivatives in the past. Specifically, the relationship between derivatives and motion. So for r of t, the position vector of like a particle along some path that you plot in 3D. The derivative of that vector is the velocity of the object and a of t equal to v prime of t equal to r double prime of t, however you prefer to write that, is the acceleration. And so usually I would have you all do maybe like this for your second participation problem for the week, but I think I'm going to keep your problems pretty light this week so that we have time to work on the project, which is on this topic anyhow. So for example, if we have the vector valued r given by cosine t I hat plus sine t j hat plus t cubed k hat. We're just going to say that's shaping the path or tracking the path of a particle moving in 3D. And so the velocity is v equal to r prime of t. And like we saw earlier, to take this derivative, we just do it component-wise. The derivative of cosine is minus sine t I hat. The derivative of sine is cosine t j hat. And the derivative of t cubed is 3t squared k hat. That's our velocity vector. And then the acceleration is going to be a equal to v prime of t. So that's going to give us a minus cosine t I hat. Minus sine t. Minus sine t j hat plus 6t k hat. And then, let's see. If we recall, speed is kind of the magnitude of velocity, how much you're moving, not necessarily the direction. We could also compute speed just being the magnitude of v. So that's going to be the square root of each component squared. So sine squared t plus cosine squared t plus 3t squared squared. And since sine squared plus cosine squared is 1 for all t, it's okay if you don't remember that. I'm just going to tell you it's true. That's 1 plus 9t to the 4th. So, for example, at t equal to 2, the speed is square root 1 plus 9 times 2 times 2 is 4, 4 times 4 is 16, 9 times 16, 126. That doesn't look right. Um, 16 times 9 is 54. 9 times. So that's going to be square root 145 is how quickly it's going. I guess that'd be like in units per second or something. And there's a lot more analysis we could do of these assorted equations, but we're going to go ahead and save that for next up. I'll do another example, but this one will be kind of like a word problem.